In this video, we'll talk about how to use double angle formulas in trigonometry. So I've listed out each of the double angle formulas here. We have the sine of 2x is equal to 2 times the sine of x times the cosine of x. The cosine of 2x, there's actually three equivalent ways to write this. The first is the cosine of 2x is equal to the cosine squared of x minus sine squared of x. We could also write it as 1 minus 2 times the sine squared of x, or we could also write it as 2 times the cosine squared of x minus 1. And then our last one is the tangent of 2x is equal to 2 times tangent of x divided by 1 minus tangent squared of x. So let's work through a couple examples of how to use these double angle formulas. Let's say we're told that the sine of theta is equal to 5/13. And let's say we're told that theta is between 0 degrees and 90 degrees. Let's see if we can find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So it helps if we can kind of visualize the situation. So if we have the unit circle here, we know that the angle, some angle, has a sine of 5/13. So if we make a right triangle out of this, remember our acronym SOHCAHTOA. SOHCAHTOA. That tells us how to calculate sine, cosine, and tangent using the sides of a triangle. So we're told that the sine of theta, the sine of this angle, is 5/13. So the opposite, sine is calculated as opposite over hypotenuse. So that means the side opposite of this angle must be 5, and the hypotenuse of this particular triangle must be 13. So before we go any further, it helps if we can first solve what's the length of this side right here, just so that we know every side of the triangle. Well, it's a right triangle, so that means a squared plus b squared must be equal to c squared, where c is the hypotenuse. So if we fill in that information, we have a squared, let's call it 5 squared, plus b squared. We don't know b, but we know that c is the hypotenuse, so 13 squared. So we get 5 squared, that's 25, plus b squared is equal to 13 squared. So 13 squared is 169. To solve for b, we can subtract a 25 from each side. So b squared is equal to 169 minus 25, that's 144. And then to solve for b, we can take the square root of each side. So b is equal to the square root of 144, which is 12. Okay, so this side of the triangle is 12. So now that we know all three sides, we'll be able to find every double angle. So let's start with sine of 2 theta. How can we figure that out? Well, let's use this formula that we have. 2 times the sine of theta. So we know the sine of theta is 5/13 times the cosine of theta. So the cosine, that's calculated as the adjacent side over the hypotenuse side. So the adjacent side is 12 over the hypotenuse is 13. So 12/13. And now all we have to do is just multiply these values straight across. So it helps if we write this 2 as a 2 over 1. So 2 times 5 is 10, times 12 is 120. So in our numerator we have 120, and in the denominator we have 1 times 13, that's just 13, times 13. So 13 times 13 is 169. So the sine of 2 theta is 120 over 169. Okay, let's make some room here. How about the cosine of 2 theta? So we can use any of these three formulas that we'd like to calculate the cosine of 2 times some angle. I'll choose this middle one right here, just for simplicity, since we only need to know sine. So let's write 1 minus 2 times sine squared. So sine we know is 5/13, and that will be squared. So we get 1 minus 2 times 5 squared is 25, and 13 squared is 169. So if we do 2 times this fraction, we'll get 1 minus 2 times 25 is 50. So 50 over 169. If we'd like, we can rewrite this 1 as a fraction with the same denominator as this fraction. So we can write it like this, 169 over 169, because that's equal to 1, minus 50 over 169. So our final answer will be 169 minus 50, that's 119 over 169. So that is what the cosine of 2 theta is equal to. All right, let's make a little room for our last one, the tangent of 2 theta. So the formula we can use here is 2 times the tangent of theta. So 2 times the tangent of theta. So tangent is opposite over adjacent. So the opposite side is 5. The adjacent side of this angle is 12. So that's 5/12. So 2 times 5/12. And that will be over, we have 1 minus tangent squared of x. So 1 minus 5/12 squared. So in the numerator we have 2 times 5, so that's 10/12. And the denominator we have, this is 5 squared, so that's 25. Over 12 squared is 144, so 144. So we get 10 over 12 divided by, it helps to rewrite this 1 as a fraction with the same denominator as this fraction. So 144 over 144 minus 25 over 144. So the denominator becomes 144 minus 25, that's 119 over 144. And then in the numerator, we still have 10 over 12. So before we go any further, it would help to reduce the numerator to 5/6. So we have 5/6 divided by 119 over 144. So remember, when we divide fractions, that's the same as multiplying by the reciprocal. So what we really have is 5 over 6 times the reciprocal is just, remember, you switch the numerator and the denominator. So we have 144 over 119. So if we want to multiply straight across, it turns out that 6 will go into 144 exactly 24 times. So we can actually reduce this, make this a 1, and make this a 24. So now we can multiply straight across. 5 times 24, that's 120. And in the denominator, we just have 1 times 119, that's 119. So our final answer is the tangent of 2 theta is equal to 120 over 19.